if a sigma a n z raised to power n is given power series with the radius of convergence r, then r is equal to limit modulus of an upon an plus 1 if the limit exists. Now proof: let the limit an upon an plus 1 exist. Suppose that z is less than r is less than alpha, and there exists an integer n such that r is less than modulus an upon an plus 1 for all n is greater than equal to capital N. Let b is equal to modulus of an into r raised to power capital N, then modulus of an plus 1 rn raised to power n plus 1 capital N plus 1 is equal to modulus of an plus 1 r raised to power n is less than equal to an modulus of an r raised to power n is equal to b. Modulus an plus 2 into r raised to power n plus 2 is equal to modulus of an plus 2 r into r raised to power n plus 1 is less than of modulus of an plus 1 r raised to power n plus 1 is less than b. Continuing this manner, we get modulus of an r raised to power n is modulus of an rn raised to power n is less than equal to b is less than equal to for all values of n is greater than equal to capital N, but then an z raised to power n is equal to modulus of an r raised to power n z raised to power n upon modulus of z raised to power n upon rn is less than equal to b z raised to modulus of z raised to power n upon rn for all values of n is greater than equal to n. Since modulus of z is less than r, so we get a series of dominated by a convergent series. Sigma n varies from 1 to infinity modulus of an z raised to power n and hence convergent. Since r is less than alpha was the arbitrary, therefore we get alpha is less than equal to of r. Now if modulus of z is greater than r is greater than a, then modulus of an is less than r, modulus of an plus 1 for all the n larger than sum of the integer n, we get an modulus of an rn an into rn raised to power n is greater than b is equal to modulus of an rn r raised to power n for n is greater than equal to of capital N. This implies that modulus of an z raised to power n is greater than b z raised to modulus of z raised to power n upon modulus of r raised to power n. Thus an modulus of an z raised to power n tends to 0 as n tends to infinity. Hence sigma an z raised to power n diverges, and so r is less than alpha. Therefore r is less than equal to alpha, and then r is equal to alpha.